now, let's have the example 3. So the problem is to sketch the graph y is equals to 2 raised to x, y is equals to 2 raised to x plus 1, and y is equals to 2 raised to x plus 2. So describe these graphs and state its properties. So let's go first to the first part of the solution, which is to compute the function values, and of course, let's list the results in the table. So let's solve. So let's have the solution in solving the values or the ranges of our three functions. Y is equals to 2 raised to x, y is equals to 2 raised to x plus 1, and y is equals to 2x plus 2. Y is equals to 2 raised to x plus 2. So since the exponential function is in this form, so our domain here for these three functions is set of all real numbers. So let's have again from negative 2 to positive 2. So we have y here, y of negative 2 is equals to 2 raised to negative 2. So we just substitute negative 2 to the value of our x. So we have equals to 1 over 2 raised to 2, that is equals to 1 over 4. For y of negative 1, we have 2 raised to negative 1, so this is also equals to 1 over 2 raised to 1, that is equals to 1 half. For y of 0, we have 2 raised to 0, which is equals to positive 1. That is because your exponent is 0, so meaning in every basis that you have a 0 exponent, you will inculcate the value that is always equals to positive 1. So let's have the y of 1, which is 2 raised to 1, that is equals to positive 2. And y of 2, we have 2 raised to 2, so we substitute to our exponent the 2, so we have 2 squared, which is 2 times 2, that is equals to positive 4. For our second function, let's solve the value or the range for this function. Y is equals to 2 raised to x plus 1. So first, y of negative 2, we have 2 raised to negative 2 plus 1. So we just substitute negative 2 to our x. So negative 2 plus 1, so we have equals to negative 1. So our exponent now is negative 1. So we have 2 raised to negative 1, that is equals to 1 half. Y of negative 1, we have 2 raised to negative 1 plus 1. And this exponent is negative 1 plus 1, that is equals to 0. So 2 raised to 0 is equals to positive 1. Let's substitute 0. Y of 0 is equals to 2 raised to 0 plus 1. So meaning 0 plus 1, that is 1. So that is 2 raised to 1 is equals to 2. Y of 1 is equals to 2 raised to 1 plus 1. So we have 2 raised to 2. So that is equals to 4. And y of positive 2, we have 2 raised to 2 plus 1. So that is 3. So we have 2 raised to 3. We have equals 8 because 2 times 2 is equals to 4. Again, times 2 equals to 8. And last function, we have y is equals to 2 raised to x plus 2. So this time, our exponent is x plus 2. So let's substitute to our values of x, the domain. So we have negative 2 here. Y of negative 2 is equals to 2 raised to negative 2 plus 2, that is negative 2 plus 2, that is equals to 0. So 2 raised to 0, that is equals to 1. Y of negative 1, we have equals to 2 raised to negative 1 plus 2. So negative 1 plus 2, that is the same to 2 minus 1. So we have 1. So 2 raised to 1, that is equals to 2. And then y of 0, that is equals to 2 raised to 0 plus 2. 0 plus 2, that is 2. So we have 2 raised to 2 or 2 squared. So meaning we have 2 times 2, that is equals to 4. And y of 1, we have equals to 2 raised to 1 plus 2. So 1 plus 2 is equals to 3. So our exponent is 3. So 2 times 2 times 2, that is equals to 8. And last, we have y of 2, which is equals to 2 raised to 2 plus 2. So 2 plus 2 is equals to 4. So our exponent now is 4. 2 raised to 4 is equals to 16 because 2 times 2 times 2 times 2. So 2 times 2, that is 4, times 2, that is 8, and times 2 again, that is 16. So let's write it in this table. So we have the range of the first function 1/4, 1/2, 1, 2, and 4. For our second function, we have 1/2, 1, 2, 4, and 8. And last, we have 1, 2, 4, 8, and 16. So this table of values is needed for our second part. Again, we need to plot the points on a Cartesian plane and connect them with a smooth curve. So those points, ordered pairs, should be plotted in our graph, in our plane. And in order to have a graph, to sketch a graph, you need to connect it, of course, with a smooth curve since it's exponential. Remember that. So let's have our graph. So these values, when we plot it, this will be the graph. For the first function, y is equals to 2 raised to x, this is the red curve. The red one is for y is equals to 2 raised to x. And for the y is equals to 2 raised to x plus 1, this is the black curve. So when we plot negative 2, comma, positive 1/2, so we have this point. When we plot negative 1, this is negative 1 from our x to positive 1, which is from y, so we have this point. And 0, we have 2, and then 1, we have 4, and then 2, we have positive 8 to our y. And last, for our third function, we have this blue curve. When we plot it, we have negative 2, then our y is positive 1, negative 1 to our x, we have positive 2, we have 0 to our x, we have positive 4 to y, and then positive 1 to x, we have positive 8, and positive 2, we have positive 16. So it can be plotted up from positive 16. So here are the properties of our function, these three functions of graph and graph. So the domain of these three functions is the set of all real numbers. So because as we can see in its form, and the range is set of all positive real numbers. So it's still from 0 to infinity. So as we can see, there are no negative values here. And for the y-intercept of f of x equals to b raised to x plus h, wherein our h here is the constant term in the expression of our exponent. So the y-intercept will be equals to b raised to h. That is your base raised to the constant term in your exponent in the expression of your exponent. So in the first graph, we have, so thus the y-intercept for y is equals to 2 raised to x. So for our first graph is 1. How it becomes 1? Because our constant term, we don't have constant term, that means that is 0. So 2, our base is 2 raised to 0, so that is equals to 1. So that means that's why this the y-intercept for this red graph for the first function is equals to 1. For y is equals to 2 raised to x plus 1, so our h is 1. So 2, so our base is 2 raised to 1, that is equals to 2. So that's why our y-intercept here is, for the black curve, is 2. So it coincides 0, 2. And last, for our third function, we have y is equals to 2x plus 2. Our constant, letter h, is equals to positive 2. So when we get the y-intercept, we have 2 raised to 2 because 2 is our base and 2 is the constant h. So 2 squared, that is 4. That's why we have this 0, 4, which is the y-intercept for this blue graph, which is y is equals to 2 raised to x plus 2. And all these graphs have the same horizontal asymptote. So since they are all still in the form of f of x equals to b raised to x, so our horizontal asymptote is still y is equals to 0, meaning this x-axis. They will all approach, those curves will approach this y is equals to 0 or the x-axis, but it will never touch us. That is the meaning of the horizontal asymptote. And these are the remarks for these graphs. So we can say that the graph of y is equals to, again, f of x equals to 2 raised to x plus 1 shifts the graph of f of x equals to 2 raised to x 1 unit to the left. So when we observe keenly these graphs, so this f of y is equals to 2 raised to x is when we shift this 1 unit to this from right to left, so we will have this graph, this black rather curve, which is y is equals to 2 raised to x plus 1. So 1 unit to the left because we have plus 1. So the graph of y is equals to f of x equals to 2 raised to x plus 2 shifts the graph of f of x equals to 2 raised to x 2 unit to the left. So this red curve, when we shift it 2 units, it will become this blue curve. So as you can see, when we move 1, 2 units, this will be the blue curve. The function, the graph for the function y is equals to 2 raised to x plus 2. So, conclusion, the graph of y is equals to b raised to x plus h shifts the graph of y is equals to b raised to x, so the original form, to h units to the left. So, since your constant term is plus h, you can conclude that it will be shifted to the left. But when the value of your h is negative, it will be shifted to the other side, to the opposite side, which is to the right. So that's it for our example number 3.